Hello everyone, my name is Rohit Singhal and we were discussing about the topic redox reactions. The second example of the redox reaction is decomposition reactions. Now, what decomposition reactions is? Totally opposite to combination reaction. It is opposite to combination reaction. In combination reaction, what we see ki two or more than two reactants combine to form a product, whereas in decomposition reaction one product or so let us say one compound dissociates to give in to dissociates into more than two products. For example, H2O on heating water dissociates itself into hydrogen gas and oxygen gas. The decomposition reaction means that one compound dissociates itself into two or more than two products. Okay. That is completely opposite to the combination. Combination means combining the reactants and forming one product, whereas decomposition is dissociating one compound into two or more products. Okay. Now, we will see whether this is redox reaction or not. We know in water oxygen has an oxidation number of -2, water has an oxidation H has an oxidation plus 1, H2 is 0, O2 is 0. Now, see oxidation number of hydrogen is whether it is getting increase or decrease, it is getting decrease, that is reduction. For oxygen it is getting -2 to 0, increasing -2 to 0, increase in oxidation number. Do not just see the magnitude, also see the plus and minus sign. This is oxidation. Another example is KClO3. On heating, it dissociates itself into KCl plus O2 gas. Again, calculate the oxidation number of each and every element. Potassium group 1 plus 1, chlorine, let us say we will calculate chlorine later on. We know about the oxygen is -2. Now, we can calculate for chlorine plus 1, let us say chlorine for chlorine we assume it is plus x, for oxygen plus 3 oxygen and 1 oxygen corresponds to -2. Okay. So, we will solve for x 1 plus x minus 6 equals to 0, x is equals to plus 5. That means, the oxidation state of fluorine in KClO3 is plus 5. In oxygen, it has an oxidation number of 0, KCl plus 1 minus 1, right. Now, you see the chlorine has an oxidation number of plus 1 in the reactant side, whereas it goes to -1 in the product. It means decrease in coordination number, reduction. Potassium have same oxidation number plus 1 and plus 1 in both the sides, that means potassium is not undergoing any kind of redoxing, whereas oxygen going from -2 to 0, this is oxidation. Okay. This is the example of decomposition reaction, where one product or one compound dissociates itself into the two or more than two products, and we can see whether it is redox reaction or not by calculating the oxidation number of each and every element, and we will see which element is getting oxidized and which element is getting reduced. Okay. Okay. Now, okay, it is also not necessary that every decomposition reaction is a redox reaction. Because there can be non redox decomposition reactions also. For example, calcium carbonate. On heating, calcium carbonate dissociates itself into calcium oxide and carbon dioxide gas. If I calculate for calcium, we know it belongs from plus group 2, So, plus 2, oxygen is minus 2. We calculate from carbon, plus 2 plus x minus 6 equal to 0, x is equal to 2 plus 4. For calcium it is again plus 2, oxygen is again minus 2, carbon it is again minus 2, carbon is again plus 4. Okay. So, if you see calcium has an oxidation number of plus 2 in reactant as well as plus 2 in product, carbon has a plus 4 oxidation number in reactant and plus 4 oxidation state in the product. Oxygen has a plus minus 2 oxidation state in the reactant side and minus 2 oxidation state in the product side. That means, it is not a redox reaction. It is not a redox reaction. And if someone asks why it is not a redox reaction, no change in oxidation number, no change in oxidation number of any element. It means, no element is been reduced or no element has been oxidized. Okay. So, it is not that every decomposition reaction or every thermolysis reaction is a redox reaction. You have to see that which reaction is redox or which reaction is not redox by calculating, by seeing the oxidation number and whether the oxidation number or there is an the oxidation number are getting increase or decrease. Okay. So, that is how you will see whether any reaction is redox or not. Third type of reaction that is redox reaction is displacement reaction. Okay. Now, displacement reaction. Now, what displacement reaction is? Displacement reaction is of this kind, that one of the reactant is present in the elemental form, whereas another forms a compound. Okay. This is the basic or general formula of any displacement reaction. What happens is, there will be one of the reactants will be in the at elemental form, but not the not the both, only one reactant, is present in its so one reactant is present in elemental form and it displaces the other Okay. Now, what is happening is only one reactant is present in its elemental form and it displaces the other compound. For example, in this case displaces the YZ to itself form a compound of XZ and remain the Y into the elemental form, and other compound goes into other one. Better I will be explaining it through the examples. In general, you will not be able to understand that much. It is basically characterized into two things. One is metal displacement. Okay. Metal displacement. Now, by reaction I will show you first. Now, then you will remember that we have done such kind of reaction. Copper sulphate plus zinc. Remember, we have done this reaction while we were discussing about the preferential oxidation and all. This copper sulphate plus zinc, this is a kind of example of displacement reaction, where zinc displaces the copper in the copper sulphate solution to form zinc sulphate plus copper. Zinc displaces copper in copper sulphate solution to form what? Zinc sulphate and copper metal. Okay. So, this is kind of metal displacement, that means one metal is displacing another metal, one metal displaces another metal. Okay. So, we know this is a redox reaction, we can also calculate the oxidation number. For for oxygen we know it is -2, okay. For sulfur it is +6 and for copper it is +2. Okay. You can calculate on its own, this will be the oxidation number. For zinc it is in elemental form, so it is 0 oxidation number, right. Copper again it is 0, zinc sulphate +2, because sulphate is -2. Okay. So, zinc is +2, oxygen is -2 and sulfur is +6. That means, copper has gone from +2 to +0, copper +2 to +0, whereas zinc has gone from 0 to +2. Copper has undergone reduction and zinc has undergone the oxidation. Okay. So, this is what the metal displacement is. Metal displacement is one metal displaces another metal from its compound. Okay. Now, you can see other examples also. For example, Cr2O3 plus Al, aluminium, it forms Al2O3 plus 2 chromium metal. I am writing the balanced redox reaction. Okay. Now, this reaction, let us calculate the oxidation number, right. For aluminium 0, elemental form, chromium 0. Okay. Now, to calculate for oxygen, we know oxygen is -2. Okay. Most of the times oxygen is -2 only, oxide form. Otherwise, if mentioned, either you have been mentioned that is peroxide or superoxide, otherwise you most of the times it will be -2. Chromium we can calculate, it will be +3. For aluminium here it is what, +3. Okay. Now, you will see ki which element is getting oxidized, reduced, chromium going from +3 to 0, aluminium going from +0 to +3. This is oxidation. Now, remember that we have discussed this thing, that how not every decomposition reaction is a redox reaction. Similarly, it is not possible that every this metal or displacement reaction is a redox reaction. Okay. You just check whether the reaction is redox or not by just seeing the oxidation number. If there is a change in oxidation number of any element, it will be a redox reaction. Okay. The second kind of this is non-metal displacement. One I have discussed is metal displacement. Metal displacement, what is metal displacement? Where one metal displaces another metal in its compound. Okay. This metal displacement, okay, one most important thing, that the reaction I have shown for copper sulphate plus zinc gives zinc sulphate plus copper. This displacement reaction has a very important application. If I talk application of this kind of reaction, application in metallurgy, you might have studied or you might study in the higher classes, you might have studied I think class 11th only about topic metallurgy, where we can by this displacement reaction, it is one of the good method to purify metal or to isolate metal from its ore. Okay. Pure metals can be obtained from the ore using these displacement reactions of the metal displacement reactions. Now, carrying on to the forward this non-metal displacement. Now, what non-metal displacement is, let us do one of the examples, then we will better be able to understand. Okay. Now, non-metal displacement. Non-metal displacement redox reactions include hydrogen displacement. Okay. That means, hydrogen has been displaced. If you see, the hydrogen initially in the reactant is present in the water molecule. In the product, it goes to the this sodium. That means, hydrogen has been displaced. This include hydrogen displacement. Hydrogen, or we can say oxygen. Generally, the non-metal displacement are either oxygen displacement or the hydrogen displacement. Now, these alkali metals, this we know this is alkali metal. Alkali metal readily reacts with water to form its alkali hydroxide, and alkali hydroxide we know are basic in nature, NaOH, KOH, cesium hydroxide, these all are basic in nature. So, these all the group 1 alkali metals readily reacts with water to form the alkali hydroxides. Now, whether this reaction is redox or not, again the oxidation number same thing, sodium 0, oxygen -2, hydrogen +1, sodium +1, oxygen -2, hydrogen +1, okay. Hydrogen it is 0. Now, sodium has gone from 0 to +1 oxidation state, oxidation, okay, and hydrogen has gone from +1 to 0. Reduction, okay. Now, the hydrogen has been displaced, to give the evolution of hydrogen gas. There are several reactions where oxygen gas are also released. Okay. So, this is the metal non-metal displacement, and hydrogen, that means including the hydrogen displacement. The hydrogen has been displaced in form of hydrogen gas. Okay. There are several examples for these non-metal displacements also. One of the examples I have shown where the alkali undergo hydrolysis to form the alkali hydroxide. The next can be the examples of let us say alkaline earth metals, for example, magnesium. These also reacts with water readily, but though on heating to form magnesium hydroxide plus H2 gas. Okay. This hydrogen gas has been released, non-metal hydrogen gas evolved. Okay. That means displacement of hydrogen. Now, if you see the oxidation number, I am just writing now the oxidation number which has been changed. Magnesium has gone from 0 to +2, that means oxidation, and hydrogen has gone from +1, so 0, that is reduction. Okay. So, this is also a redox reaction where alkaline earth metals reacts with water to form alkaline hydroxide, alkaline earth metals, group 2 metals reacts with water to form group 2 hydroxides, in which the hydrogen gas has been displaced, giving the example of non-metal displacement redox reaction. Similarly, there are some metals also. There are another metals, let us say, because I have taken group 1 metals, group 2 metals, there can be group D block metals also. Some of the metals that does not react with water. Generally, there are metals that react with water to form the hydrogen gas. For example, I have shown magnesium. Magnesium on reacting with water release the hydrogen gas. Sodium on reacting with the water molecule release the hydrogen gas. Whereas, there are some metals that do not react with water to release the hydrogen gas, but the metals can react with acid to release the hydrogen gas. For example, zinc. Zinc in presence of HCl forms zinc chloride and hydrogen gas. Again 0 oxidation goes to +2 and this +1 goes to 0. That means, hydrogen has been reduced and zinc has been oxidized. Okay. So, this is again an example of non-metal displacement reaction, non-metal displacement reaction involving a redox reaction, right. Similarly, there are some metals, magnesium plus Okay. However, if you say ki zinc react with water and it will release H2 gas, no, it does not release H2 gas, whereas magnesium on reaction with water it release hydrogen gas, yes, and with reaction of acid also it releases hydrogen gas. Okay. Now, you must be thinking that in which case the hydrogen gas will get released, why the zinc reacting with acid does not release the hydrogen gas, oh sorry, why zinc reacting with water does not release the hydrogen gas, why whereas magnesium on reacting with water as well as with the acid release the hydrogen gas. Okay. This we will see on the basis of a reactivity order that I will discuss in the next class. Till then, thank you.